All right, this is 2018, 6 through 10. The answers are 6B, 7C, 8E, 9C, 10E. So as always, just watch the ones you need to here. So looking, excuse me, at number 6. So they're asking about the margin of error. So why is the margin of error A bigger than B? Or potentially, why is it bigger? Okay, so I've got the formula for margin of error here. This is what's used to calculate margin of error. So a lot of them are referring to the sample size. The first 3 are, and we don't know the sample size of each of them. When I look at D, they talk about the mean of A being greater than the mean of B, which is true, but when we look at the margin of error calculation, the mean does not factor into that at all. So this one would be out. The standard deviation of A is less than B. That's correct. But if I have a smaller standard deviation, that's going to overall make the entire margin of error smaller. Okay, so what it must be talking about is N, the sample size. Okay, so if I am going to have a bigger margin of error, that means I would need to be dividing by a smaller number. Okay, so it has to be that the sample size of A is less than the sample size of B. Right, we know that the margin of error is smaller, so that's not, or excuse me, the standard deviation is smaller. That's not going to make the margin of error bigger. It has to be that this sample size is smaller. All right, looking at the next one here. So we're talking about converting from Canadian dollars to US dollars. So basically, what 1 Canadian dollar buys you, 75 American cents will buy you, or 0.75 American dollars. So they're saying, all right, when we convert here, which is going to stay the same? So the median, mean, those are all going to change, right? It's going to be, if the mean were $1, the mean is now going to be 0.75. Same with the median. Same with the idea of the IQR. So because I'm essentially multiplying by 0.75 to convert, that interquartile range is going to get smaller. It's also going to be multiplied by 0.75. Same with standard deviation. So when I'm multiplying by something, that standard deviation is going to get smaller because we're multiplying by 0.75. So the only option really that would make sense even is the standardized score. So standardized score is a z-score. So when we think about z-score, this just measures how many standard deviations from the mean. So if the price of something were 2 standard deviations above the mean in Canadian dollars, after everything is converted, it's still going to be 2 standard deviations above the mean in United States dollars. Okay, looking at the next one. So we've got proportions proportions distribution-wise, 18% used to order beef, 41 chicken, and so on. And now they believe that might have changed. They collected data on 200 dinners, and we have that here. So we would call this our observed data. This is what actually happened. So they want to know which contribution for the appropriate test. Okay, so this is a chi-square test. We're testing the entire distribution, and we want to know if this distribution still holds. So because I just have a list of data here, these are all my observed, I could come up with an expected list. I want to think about that contribution piece, which is that O minus E squared over E. So the calculator will do all of this for you. So kind of the easiest way to approach this one is if I'm looking at the calculator. So I put all of the expecteds here into L1, or excuse me, the observes. The observes, this is what actually happened, right? 32 ordered beef, 86 ordered chicken, and so on. These are the expected. So beef was 0.18. So 0.18 of 200 people is 36. 0.41 for chicken of 200 people is 82, and so on. So I've got my observes and my expecteds. So when I go ahead and run this test here, right, the chi-square goodness of fit test, I've got my observed and my expecteds. There are 5 choices, so my DF would be 4 still. Okay. So what I want to pay attention to here is the very bottom. This is the contribution. This is O minus E squared over E for each one. So like this is the contribution for beef. This is the contribution for chicken. So we wanted to know which is the greatest, which contribution is the greatest. So I'm just looking for the value that's the biggest. So far 0.5 is the biggest. 2.5 is bigger, and 3 is definitely the biggest. So this goes with our last one, which is the vegetarian option. Okay, so vegetarian had the biggest contribution of 3, so that's the biggest or the greatest contribution. Okay, looking at number 9, this one is definitely a tricky one here. So we have x and y, and then we're making this new variable, w, which is equal to x plus y. Okay, so really, though, we have 10 of each of them. We have 10 x's and 10 y's. So when we're thinking about finding the standard deviation, we have to rely on this variance formula for random variables. So the variance of x plus y is equal to the variance of x plus the variance of y. Okay. However, we want standard deviation, so we would have to take the square root of each side. So we need something that follows kind of this format here. Okay. The difference is, though, that we have to consider is we have 10 of each of these. We have 10 x's, or not 10 of each, excuse me, 10 x's and 15 y's. So really what we would have would be the variance of x plus the variance of x, right? We would do that 10 times because there are 10 of them, which is the same thing as saying, right, if you're adding 10 of the same thing, it'd be 10 times the variance of x, and we're going to have 15 y's, so 15 times the variance of y. Okay, so we know the variance of x and y. They give them to us are 1.3 and 0.5. So we're just plugging in 1.3 here and 0.5 here. So the one that follows that is C. All right, last one for this set then. So they give us the probability that a person owns a dog, the probability that a person, or a household, I should say, owns a cat, and they want to know the probability that they own a dog or a cat. So we're trying to find the union, so the probability of dog or cat. So when we think about this, formula, right, this is our general addition rule, so we would do probability of dog plus probability of cat, that's all fine, we know those, minus the probability of dog and cat. Okay, so we would need to know this probability of dog and cat, which they don't give it to us. So in this case, we don't have enough information. Sometimes we see questions like this where they say that the two are independent. They did not tell us that here, but if they were independent, we could find the intersection by multiplying them. So it's just something to watch out for.